students, welcome to Legacy IAS Academy. In today's video, we are going to discuss about the deep sea mining. What does deep sea mining basically stands for? What are the prospects and challenges in this particular process of mining? And the authority that is called as International Seabed Authority that is responsible for the allocation of mines as well as regulating the mining procedure in the deep sea areas. What is this organization major roles, mandate and background? That is also we are going to discuss in this particular video. So first of all, to give the context that why this particular issue is news recently. So very recently, few days back, actually the ISA, that is the International Seabed Authority, that is a body functioning under the aegis of United Nations. It has actually started and resumed the negotiation for granting and allocating of mines in the high seas region. It could thus open the international seabed in different parts of the ocean for various activities such as mining, exploration, research and development, including for such materials which are very critical for the transition to the green energy. The negotiation which was going on for years long have finally reached a critical point where the authority will soon basically need to begin accepting mining permit applications from both government authorities as well as the private participants. It also is adding to worries, however, among the mind of environmentalists and the conservationists that the potential impact of such kind of mining, if it is done over a large part of the ocean, over a large area of the ocean, can have disastrous impact on the marine ecosystems as well as the habitats of the deep sea region. So first of all, let us try to understand what is this body international that is ISA. So ISA is a body which is headquartered in the Kingston city. Kingston is the capital of Jamaica, and Jamaica is a small island country that is part of the Caribbean islands of the coast of USA in the North Atlantic. So this organization basically is a organization that is having membership of 167 member states, which all of these are obviously the member of United Nations. And apart from that, 25 states or nations that is a part of European Union. So overall, it is a body having 191 member states. As far as the establishment of this organization is concerned, it dates back to somewhere about 1982 when we have a signing of UN Convention on the Law of Seas, also called as UN clause. And thus, after the signing of UN clause, in 1994, agreement was made for the implementation of the convention's features, and thus ISA was set up to basically oversee two major functions. And thus we can say the two major missions, dual mission of ISA is first to authorize and control development of mineral related operations in the international seabed. International seabed generally refers to the area in the ocean which is lying away or ahead of the exclusive economic zone of any coastal state. So after authorizing and controlling development of mineral related operations, it also has to make sure that the ecosystems present on the seabed, on the ocean floor and in the subsoil areas in the area beyond nation's jurisdictions are also given adequate protection. And in this regard, we can say the ISA is thus has to safeguard the international seabed area, international deep sea region, the region which basically lies below 200 meters or 656 feet in the depth, where photosynthesis is hampered by the inadequate light. So the area of the sea where the photosynthesis is possible, that is called a eutrophic zone, where the sunlight is able to penetrate deeper into the surface. But beyond 200 to 300 meters, what happens? The sunlight start to disappear, and thus no photosynthesis is possible. Thus no autotrophs can actually survive in this area. So the safeguarding of this particular region of the ocean is the main or primary duty of the International Seabed Authority. Now, if we talk about the deep sea mining, what does deep sea mining basically means? So deep sea mining basically involves removing and extracting of such mineral deposits and metals from the seabed of the ocean. That means we have the water and we have the exclusive economic zone, and then we have the continental shelf. And as we move away from the continental shelf of a country, generally the depth of the water start decrease, and the depth of the seabed from the sea level also start decrease. So there are many minerals that are lying as deep as 6,000 meters, 5,000 meters from the sea level. So extraction of mineral from such a greater height, a greater depth is what is referred as deep sea mining. If we try to classify it, we can classify it into three categories. First and foremost, which is also the most lucrative kind of mineral extraction, is extraction of polymetallic nodules, that is also called as PMS in the short. So extraction of polymetallic nodules off the ocean floor that is lying at 5,000, 6,000 meter deeps. Mining of seafloor sulfide deposits are there that also has to be mined. And then stripping of cobalt from the crustal rocks. So these are three major types of mining. Now, the most important and significant type of mining is the mining of PMNs, that is polymetric nodules. So what are the polymetric nodules? So polymetric nodules, many times also referred as manganese nodules, because in this the concentration of manganese minerals is very high. So these are basically a round to oblate shape of mineral concentration found on the sea bottoms, where we have concentric layers of iron and manganese hydroxide around a core. And apart from that, few other metallic minerals are also deposited and concentrated in these polymetric nodules, such as cobalt, nickel. These are the two other major minerals apart from manganese and iron that you can find in PMNs. So since PMNs are not found in a small radius, they are found in very large area in a very vast quantities, and they contain valuable metals. Deposit are identified as a potential economic interest by many countries. As far as the size of these nodules are concerned, they are not very large. They can be as small as microscopic in size to as large as 20 centimeters, that is almost 8 inches across. However, if you look at the majority of the nodules, as you can see from the picture here, they are lying somewhere between the range of 3 to 10 centimeters, that is 1 to 4 inches in diameter. That is almost, we can say, same like a size of eggs or potato. So such huge amount of millions and millions of such PMNs are lying and scattered on the ocean floor, and the many countries across the world today are making an attempt to understand or develop technologies that can help them in extracting these PMNs because many of the minerals in the PMNs are also example of rare earth. So what is the current status of the exploration of the PMNs? Now, obviously, if you look at the engineering and technology, that must be very, very advanced to carry out deep sea mining operation. It is still in a evolving phase. Many countries are there that actually looking at the vacuum materials, looking at the vacuum technology to extract materials from sea floor using massive pumps. Some countries are there, such as South Korea. They are developing artificial intelligence based technologies, and once the programs and data are fed into the machines, that would help the deep sea robots, like as we can see from this picture here, then these deep sea robots can be sent back or sent to the deeper part of the ocean, and they, on the basis of the programming, can pluck nodules from the floor. Apart from that, some other countries are trying to develop advanced machine that could mine minerals or materials offside of huge underwater mountains, also called as sea mounts or geo, that is situated in the volcanic region of the seabed. So these are the current status as far as the scientific development of technology is concerned. Now, coming to the most important phase, that how the regulation of the deep sea mining operation is carried out. So, first of all, to understand this, we have to understand the concept of maritime zone, because as per the United Nations Convention on the Law of Seas, signed in 1982, the countries agreed that they will divide the oceans into various parts, and thus their control over these different parts will vary accordingly. So, for example, if you talk about any country, suppose A is a country here, or suppose let's say India is a country here, and this is the coastal regions of India from where sea is beginning. So basically, we can divide the sea into four major parts: territorial sea, contiguous zone, exclusive economic zone, and beyond the entire ocean body is referred as high seas. So as far as the region to exclusive economic zone, that is almost 200 nautical miles from the baseline, that is near the coast, up to here, whatever minerals are found, all the mineral resources will be exclusively used and extracted by India or any other country which India decides to give the right. Apart from that, as we move away from the region of exclusive economic zone, this is the high sea region. And this is the high sea region where the International Seabed Authority comes into picture, and the regulation of mining is done by this particular body. So it is considered to apply to even a state, as since all these things are basically being guided by UN clause. So even such countries which have not ratified or signed the UN clause, the agreement is considered to be applied to these states as well. And under the treaty, the seabed and its mineral resources that is present in the high sea area are considered the common heritage of mankind. And that is why many times high seas are also referred by a common term of global commons. So thus, since these resources are the common heritage of mankind, belong to the entire mankind, the management of these resources must be done in such a manner that protects the interests of humanity to the sharing of economic benefits and support for scientific research, as well as protecting the maritime environment. That means both The responsibilities also lie on all the mankind, as well as the resources or the benefit, monetary benefit, economic benefit that anyone is getting from these resources must also be shared across the entire humankind, entire countries. Apart from that, if you look at the current status of mining, so mining companies obviously are interested in deep sea exploitation, and thus they are partnering with different countries to help them get the exploration licenses. And as far as now, more than 30 exploration licenses have been issued so far, with activity that is mostly focusing in the Central Pacific Ocean. If you look at this red zone area here, this zone is what is referred as Clarion-Clipperton zone, and most of the licenses to mine deep sea minerals are provided or given in this particular zone. This zone basically spans over a very large area, almost 4.5 million square kilometer, lying somewhere between Hawaiian Island in the east and the Mexico coast in the west. So this is where we have the huge concentration of polymetallic nodules as well as cobalt crusts as well. However, despite all these economic benefit that we can get from the deep sea mining, there are many environmental concerns that has been raised by the biologists and conservationists. For example, the damage to ecosystem, especially if we have not put into place some environmental protocols associated with mining, can have huge implications on the ecosystem. For example, it is believed that due to mining operations, there can be large-scale pollutions which will be generated, which can be in different ways, like noise pollution due to the continuous moving and the flowing of the machines, the vibrations due to this movement in the earthquake. The earthquake can also occur. There can be seismic events that can happen, and also the light pollution, because obviously when the machines and ships will move into this area, they will actually increase the light in these areas. So all this can actually affect the marine animals that are living in earlier unpolluted kind of environment. Second, also because the ships are continuously plying through these areas, the resources will continuously extracted. Thus, there is a high chance of possible leaks and spills of fuels and other chemicals that can be used in the mining process. And the most disastrous of these can be what we refer as sediment plumes. That means, for example, after the mining is carried out, once the mining operation is completed, whatever slurries and waste materials are there, they can be actually dumped back into the ocean, and this will give rise to development of sediment plumes, as we can see from these areas coming from the surface of the sea and going to the bottom of the sea. So these sediment plumes can actually harm the filter feeding species, especially corals and sponges, because the amount of sediment that will generated will be so huge that the sediments can actually go and choke the coral, because the corals are very microscopic, tiny animals in size, and thus could smother them or otherwise interfere with some other creatures, their spawning activities and their overall circadian cycle as well. Thus, anyway, in the conclusion, what we can say, the full extent of the implications what we will have due to deep sea mining on the ecosystem is still unclear, but scientists have warned that the biodiversity loss will be inevitable and potentially irreversible if the deep sea mining is carried out without any proper environmental protection. So what lies ahead of now? So first of all, as we have discussed, it is the International Seabed Authority that has to take care of the entire mining operation. So Legal and Technical Commission of ISA has to meet in the July this month, July, and they will discuss about the yet to mining code draft. Earliest that mining under ISA regulation actually could begin will be 2 years from now, 3 years from, that is 2026. An application for mining must be considered, and environmental impact assessment need to be carried out. In the meantime, however, due to the what you can say, due to the environmental aspect, that is or ecological aspect of the deep mining that has not been discussed, many companies such as Google, Samsung, BMW have backed the World Wildlife Fund's call to pledge to avoid using minerals that have been mined from the planet oceans. So if the demand of such minerals decreases, obviously the mining operation itself will become not economically viable or not so much profitable. And thus more than dozen countries, also including major countries of Europe such as France and Germany, and several Pacific Island countries, have officially called for a ban, pause, or moratorium on deep sea mining, at least until environmental safeguards are put into place. However, in the same regions such as European regions, some countries are there such as Norway, who are basically that are basically propose opening of their waters for the mining. So there is obviously not a consensus that can be built on this whole process. There is a lot of economic benefit that one country can reap from the deep sea mining, and at the same time, it can come on the cost of the environmental pollution and the biological degradation. So overall, in this entire spectrum, what is the current status of India? So if you look at the India's announcement, especially of the Ministry of Earth Sciences, it has says that it is going to take up at least 3 investigation for ferromanganese crusts or nodules, that is similar to polymetallic nodules, in 3 regions of the ocean, that is the Andaman Sea, Indian Ocean, and the Arabian Sea. Government of India recently also have announced a mission that is called Deep Ocean Mission, that will be run under the overall command and control of Ministry of Earth Sciences and with the support from Geological Survey of India, with aim to explore the ocean for resources and develop deep sea technologies for sustainable use of ocean resources. An integrated mining system thus will be developed under this deep ocean mission for mining of polymetallic nodules from 6,000-meter depth in the central Indian Ocean near the Diego Garcia Island. And it is in this context there is a ongoing development of a special craft or a special deep sea craft that is called as Matsya 6000 that can take us to a depth of 6,000 meters in the Indian Ocean. So this is still in research and development phase, but obviously if you look at the prospect and the aims of deep ocean mission, as we know that the polymetallic nodules are over 75,000 square kilometers of area international water with overall potential of 380 million tons, with the manganese being highest, as we can see from here. Thus India's mission, that is deep ocean mission, can contribute significantly in ensuring that the resources, the future resources, future mineral resources of India, as industrialization happens more and more, can be met without any interruption. So that is all about this particular video. I hope you understood about the overall basics of a deep ocean mission and what is the India's status, what is International Seabed Authority, and what are the role and mandate it is expected to perform. That is all about this particular video. Like the video, please hit the like button, share it with your aspirants, as well as subscribe to our channel for more content. Thank you.